Okay, here's the next problem. Go through this one. I'm going to find the radius of convergence. And this is starting at n equals 0. Now, you can't always do this, but on this one, I think I'm going to do it just because, well, it'll make some of our work a little simpler. Not by much, but we can reduce this to n factorial over n factorial. Let's look at that for a second. 2n factorial over n factorial. Now, first thing notice is you cannot just cross off the n factorials like they divide out. We could do a little bit of expansion. Well, let's see, 2n. Well, it's actually not going to work for us. We'll have to subtract that one. No. Okay, so let's wait on that. I'll show you what I mean in a second here about that simplifying. So again, let's set up our, let's set this up here. We're going to find this limit. In this case, it'll be, we do have to be careful about this. It's 2 times n plus 1, and then that whole thing is factorial. So you got to be careful with that. X to the 2n, again, plus a 1. And this is n plus 1 factorial. All of that. And I'm going to do the flip here just because it saves a step writing. Okay, so now let's see what happens here. Oh, and let's not forget our limit here. Okay, now in here, this is what I was attempting to do over here, but it actually can't be done at this point. So let's do this. 2n plus 2, that's a factorial. This is n plus 1 factorial. There's an n factorial up there, and a 2n factorial down here. And we're still left with an x to the second power up there. Okay, so that x to 2n, that becomes a 2n plus 2. And then the 2n's will divide out. You're left with a 2. Okay, so gotta work a little more here. This one now, I'm going to try to do some expansions here. This will be 2n plus 2 times 2n plus 1, that's 1 less, and then a 2n factorial. Down here we have this n plus 1 times an n factorial, and then we've got a 2n factorial like that. And I still have my x squared over here. Okay, now it looks like that, but okay, now you can do a little bit of simplifying here. The 2n's, 2n factorial will go away. The n factorial goes away. Also, we can take it down another step. You might notice that this can be written as 2 times n plus 1 with a 2n plus 1 and an x squared like that, and an n plus 1 down here. So we get another cancellation here. Of course, if you're looking a couple steps ahead, you realize what we're in for here. We've got a 2 with a 2n plus 1. And then you've got x squared. I don't need those bars anymore. But the point is this thing has to infinity. Okay. Now when that happens, it means your radius of convergence is 0. Remember, every power series will converge at its center, and the center of this one is a 0. If you put a 0 in for x, you will just get 0. In other words, if this is my function, then f of 0 is 0. So obviously it's convergent at that one point. This is just a 0. But this tells us that that's the only number that it's going to converge for. The radius of convergence is 0. For this case, it's not. This isn't the same 0 as this 0. Okay. It's the fact that we don't have a radius of convergence. We have nothing. The length of that radius is 0. You kind of have to. That word radius really doesn't. You have to almost think in 2 dimensions when you see, like, here's a center C, and this is this distance out here is C minus R, and this is C plus R. And the term radius actually comes as a holdover from complex number theory, and where you have a radius in the complex plane for which you have convergence. Our radius is just along the x-axis, one-dimensional. But we still call it radius. And in this case, that radius is a 0 for this problem. So it diverges everywhere except right at the center. Okay, so that would mean the interval of convergence is, well, nobody ever really writes this, but you could say the interval is this. That looks a little weird. Actually, it's this. Sorry. But nobody is going to write it that way. I mean, it's just 1 point. Converges only at 0. So anyway, that's how you handle that one.